Hello everyone, welcome to Knowledge Hub by Sri Chaitanya. So this is Lalita Devi, Senior Maths Faculty. So coming to the today's class, we are going to learn about the polynomials. Okay. So first of all, we will discuss what about the basics of the polynomials, like what are the terminologies we are going to use, and then after we will discuss and we will move to the important part of the polynomials. That is nothing but coming to here we will discuss the first degree of your polynomial, and then after value of your polynomial, and then after we will discuss the zero of your polynomial. Okay. So now moving to the first, that is nothing but what is a polynomial. So now polynomial is nothing but the collection of the terms which are having a variables and the mathematical operators between them. Okay. So now if you observe here, we are having the terms like 3x square plus 5. So 3x square is a term and 5 is also a term. And coming to here, what is the mathematical operator means? The mathematical operators you can use like your plus or minus. Now the two terms are going to be differentiated by the mathematical operator, that is nothing but your plus. Okay. So now coming to the variable, so we know the basic definition of the variable. That is nothing but if we don't know any value of any algebraic expression, we are going to use the letter in order to represent the unknown value. That unknown value we are going to consider it as the variable. So here we are having an example of 3x square plus 5. So now 3x square, which is the one term, and 5 is also a term. Okay. So now coming to the given polynomial, we are having the two terms that are nothing but your 3x square and 5. And mathematical operator is your plus. And coming to here, the variable we are going to use is nothing but whatever the letter you can see here, that you can find it as your variable. So if you observe here, we are having the letter which is nothing but x. That means the variable of these polynomial will become x. Okay. So now moving to the next, if you observe here, before the x square, we are having one of the term. So if you observe here, we are having the before x square, we are having 3. That 3 we are going to call it as the coefficient of x square. Okay. So if you take an example like your x plus 3, okay, where x is the variable. But coming to here, the coefficient of x will become 1. Why? Because when we will get the x, if we multiply our 1 with x. In the same way, if you look at here, we are having a number that is before our variable x square. That becomes the coefficient of x square. So which is nothing but your 3. Okay. So in our exponents and powers, we know that coming to here, x raised to the power 2. So now these two will become the power. Okay. Now moving to the next term, which is nothing but your 5. So if you consider your 5, here I am not having any variable. That means here I am not having any letter. So how can we represent that? Can I represent it as the x to the power of 0? Yes. So because anything to the power 0 will give you 1. So our 5 can be written as 5 into 1. So in the place of 1, we can write it as the x to the power 0. Okay. Now the coefficient of x to the power 0 will become constant. Okay. So that means our 5 will become constant. Clear everyone? So coming to here, first of all we discussed about the polynomial, and then after what are the terminologies we are going to use in the polynomial. Okay. Mostly we will talk about the terms. Okay. And next one we will discuss about the variables. That means what are the variables we are having in the given polynomial. So coming to the next, types of the polynomials. So if you observe here, we are having the different types of the polynomials based on the number of terms and based on the degree of your polynomial. So degree of your polynomial we will discuss in the next, and coming to the number of terms is nothing but, if you observe here we are having the term 1, which is nothing but our 3x square, and another term is our 5. Okay. So coming to here, we are having the two terms. That means we are going to call it as the binomial. Okay. So now binomial is having the two terms. What if I am having only one term? Like consider that x square. Okay. If you consider an example of x square, if you observe here, we are having only one term in this polynomial. So now we are going to consider it as the monomial. So monomial in the sense it is having only one term. Okay. So monomial means one term. Now let me give you another example of, if I am having 2x square plus 3x plus 4. Okay. So now if you observe here, we are having 1, 2 and 3 terms. Okay, in a polynomial, if you are having the 3 terms, means we are going to call it as the trinomial. Okay, so these will become your trinomial, which is having the 3 terms in it. So now what if we are having the 4 terms? Poly means many. So if you are having more than 3 terms, we are going to consider it as the polynomial itself. Okay. And if you observe here, binomial and the trinomial also can be considered as the polynomial, because if you are having more than one, so those are considered as your polynomial. Okay. So now based on the terms, polynomials are classified as monomial, binomial, trinomial and polynomial. Okay. So now you can consider your binomial and trinomial as polynomial also, because they are having more than one term. Clear about that classification of the polynomials based on the terms? Now moving to the next. That is nothing but our degree of a polynomial. So now let's consider an example of, I am having an example of 3x square plus 4x plus 5 equals to 0. Okay. Now if you consider in this example, we are having the variable which is nothing but our x. Okay. So variable is the x. Now coming to the first term, we are having the power of the variable as 2. And coming to the second term, you are having the power of the variable x as 1. Okay. And coming to the third term, you are having a constant. Constant means the power of the variable will become 0. That means here the power of the variable is 0. Okay. Now if you compare the powers of a variable in the terms, we are having the highest power as the 2. Okay. So now that 2 will becomes the degree of a polynomial. So finally we can say that degree of a polynomial is nothing but the highest power of the variable that we are using in the polynomial. Okay. Now moving to the next, we are having the types of the polynomials. So types of polynomials based on the degree. Okay. So coming to here, types of the polynomials based on degree is nothing but, just consider that if you are having an expression like x plus 1, if you observe here, we are having the highest power of the variable x as 1. So that means if you are having a highest power of a variable as 1, then it becomes your linear polynomial. Okay. So coming to the linear polynomial, you are having the degree of your polynomial as 1. And moving to the next example, if you consider x square plus 4. Okay. So here you can ask me that, ma'am, we are not having the x term. Yes. Understood. So coming to here, we are not having the x term also. But if you observe here, we are having the highest power of the variable as 2. That means if you look at here, if you are having a degree of the polynomial as 2, then we are going to call it as the quadratic polynomial. Okay. So coming to the linear polynomial, which is having the degree of your polynomial as 1. And coming to the quadratic polynomial, which is having the degree of your polynomial as 2. Okay. So here we can mention as degree is 1. Okay. And coming to here, the degree is 2. And what if we are having the degree 3? So you know that quadratic is the 2. And coming to the next, cubic. So if you are having the degree 3 means it will become your cubic polynomial. Okay. So cubic polynomial is having the degree of 3. Okay. So degree of 3 is nothing but the highest power of a variable which you are going to consider in the cubic polynomial will be the 3. Okay. Now what about the constant polynomial? Constant polynomial is nothing but your x. That means you are going to consider any of the numbers. So for example, if I am considering the 5, which is a number, okay, and it is not having any variable in it, so it will become your constant polynomial. Okay. As I told you, we can write our constant polynomial as the coefficient of x to the power of 0. So that means the degree of a constant polynomial will become 0. Okay. So you can rearrange it as, if you are having the degree as 0, then the polynomial is called as the constant polynomial. Okay. Yes. So if you observe here, we are having the constant polynomial which is having the degree as the 0. Okay. Now consider an example of, if I am having all my terms in a polynomial as the 0. Like if I am having 0 comma or 0x square comma 0x cube, or all these are considered as the 0 polynomials. Okay. So all these are considered as the 0 polynomials. Now for these polynomials, what will be the degree will become? So the degree is not defined for the 0 polynomials. Okay. So in your bits, they may ask you that what is the degree of a 0 polynomial? So most of us will think that 0 polynomial is nothing but the 0. So degree also will become 0. That is wrong. So coming to here, 0 polynomial is having the terms in the terms of a 0. But coming to the here, we can multiply it with x square or the x cube, or you can multiply it with your x power n also. That's the reason the degree of a 0 polynomial will be considered as the undefined. Okay, so this is the most important bit, I guess, because 0 polynomials mostly they ask what is the degree of a 0 polynomial. Most of us will think that the degree of a 0 polynomial as the 0. Okay, but we have to correct it too. If we are having a 0 polynomial means the degree will be undefined. Okay, now moving to the next, write degree for the each of the following. So let's solve a question on the degree of a polynomial, and coming to here, write degree for each of the following. So now you have to write the degree for A, B, C and D. Okay, let me help you to solve the A and B, and you can give a try for your C and D. So now if you consider your first one, that is your A, it is of minus 3, A power 4 and B. Okay, so I told you only the one variable, which is the x, but if you take an example here, we are having the two variables, that is your A and B. Okay, so coming to your grade 10, you are having the linear polynomials in two variables, where you can learn about the polynomials which are having the two variables. Now in the same way also, here the polynomial is having the two variables, but if you consider the power of A, so what will be the power of A here? Power of A is having 4. Okay, and what will be the power of B here? So B to the power, we are not having any value. Some students will think that B is not having any power, so that means it will be the 0. That is wrong, because B to the power 0 means you will get the value as 1, but here you are having B. So when we will get the value of B, if we are considering the exponents and powers, if we are having the B to the rise, B raised to the power 1, then you will get your B. Okay, so now coming to here, the power of B will become, so power of B is 1. Okay, now if you compare the power of A and power of the B, then you can observe that A is having the highest power. So now the degree of the polynomial minus 3 A power 4 B will become 4. Okay, so here the degree is 4. Now let's solve the next one. Coming to the next one, we are having A cube B minus 2A to the power of 5. Okay, so now this is the only one term, but coming to the second one, you are having the two terms. First term is your A cube B and second term is your minus 2A to the power of 5. Another important thing in the polynomials is you have to consider the sign that you are having for the coefficients also. So most of us will leave the coefficients, but when it comes to the general representation of a polynomial, we are going to consider whatever the sign we are having for the coefficients, because in general representation, if you take for your linear equation, it will be of ax plus b equals to 0. Okay, that means whatever the general representation we are using, there we can see only the plus sign, but in the given question they may be having the minus sign also. That minus sign comes under the coefficient part. So now if you look at here, first one is your A cube B and second one is your minus 2A to the power of 5. Moving to the A cube B, the power of the A is nothing but 3, and coming to the B, the power is 1. Okay, and moving to the next term, that is our minus 2A to the power of 5. What is the power we are having? 5. If you compare the power of A and B here, we are having the highest power for A, and that highest power value is 5. So now the degree of the second one will become 5. Okay, so now let's solve the third one. So coming to the third one, 2u plus u cube plus 3. Okay, so now here we are having the 3 terms. It would be better if you write the terms differently, means then only you can understand what is the power of a variable in each term. So now if you consider your first term, that becomes to your 2u, which is having the u to the power of 1. Okay, and coming to the u cube is having the power of 3. And coming to the constant, 3 is our constant, which is having the power of a u as 0. Now if you compare the powers 1, 3 and 0, now u is having the highest power as the 3. Now the degree will become 3. Okay. So can I give the next question as your homework question? But be careful about the fourth question, because if you first look at the 4x power 4, you can think that that is the power. Okay. It is not, it is not mentioned anywhere that we have to start with the highest power. So you have to compare each and every term that you are having in the polynomial. Then only you can understand what is the highest power of the variable you are having. So let's move to the next one. Moving to the next is nothing but your value of your polynomial. So value of your polynomial is nothing but if we are having a polynomial in the form of a p of x, that means I am representing my polynomial as the p of x, which is nothing but you are just consider x plus 1. Okay. Now I need to find the value of p of 1. Okay. So p of 1 is given by replacing the x with 1. That means simply you can remember that whenever you are having x, wherever you are having x in the polynomial, in the place of x you have to place the value 1. So coming to here, I am having p of x equals to x plus 1. So I need to find the p of 1 value. That means in the place of x I have to place the 1. So it will become your 1 plus 1, which is nothing but your 2. Okay. So don't think that finding the value of your polynomial is easy. That is easy only, but you have to read the question carefully. If you need to understand what is the value we have to find for the polynomial. Okay. So now let's solve an example. So find p of 2 if p of x equals to x square plus 4x plus 4. Okay. So now first of all write what is the given polynomial. So the given polynomial is p of x equals to x square plus 4x plus 4. Now they are asking us to find the value of p of 2. So we have to find the value of p of 2. That means wherever you are having the x in your polynomial, you have to replace that x with 2. So here it will become 2 square plus 4 into 2 plus 4. So now 2 square value is 4 plus 4 2s are 8 plus 4. So now you know that 4 plus 4 will give you 8. 8 plus 8 will give you 16. Okay. So finally we got the p of 2 value as 16. Okay. So don't get confused what is the p of x. So p of x is nothing but it is the representation of your polynomial in the terms of x, or you can read it as in the variable of x. Okay. Now let's solve a problem on finding the value of your polynomial. Now find p of 0, p of 1 and p of 2 values for each of the following. So most of the students will think that here we have to find the 3 values and here we are having the 4 questions. So p of 0 we have to find for the first one. That is wrong. You have to find the p of 0, p of 1 and p of 2 for the first question. Okay. And for the second and third and fourth individually. That means if you take your first one, p of y is given by y square minus y plus 1. Okay. Now for this polynomial also I have to find my p of 0 value and p of 1 value and p of 2 value. Okay. So we mostly observe the students finding only p of 0 value for the p of y, because here they seen that first of all we have to find the p of 0 and here the first question is p of y. So that means if we find the p of 0 for p of y means that's enough. That's wrong. Okay. So you have to find the 3 values for your first polynomial, that is nothing but your p of y. So now if you want to find the p of 0, it will be of 0 square minus 0 plus 1. So we know that 0 square will give you 0, 0 minus 0, 0, 0 plus 1 will give you 1. Okay. Now moving to the next, p of 1 value we have to find. So that becomes your 1 square minus 1 plus 1. 1 square value is 1. And now plus 1 and minus 1 will get cancelled and you will get 1. Okay. Now moving to the next, p of 2 value, that becomes your 2 square minus 2 plus 1. Okay. 2 square will become 4 and 4 minus 2 will give you 2 and 2 plus 1 will give you 3. Okay. In the same way, let's find for the second question also. So coming to here, they gave the p of t. P of t means we are having the polynomial in the variable t. So it is given as 2 plus t plus 2t square minus t cube. Okay. So now First of all, find the p of 0 value. So p of 0 value will become 2 plus 0 plus 2 into 0 square minus 0 cube. Okay, so 2 into 0 square will give you 0 and 0 cube will give you 0. So now what it will become? 2 plus 0, which is nothing but your 2. Okay, so now let's find the p of 1 value. P of 1 value is given by 2 plus t. In the place of t I have to write my 1. 1 plus 2 into 1 square minus 1 cube. So now it will become 2 plus 1 plus 2 into 1 square is nothing but your 2 minus 1. So minus 1 plus 1 will get cancelled and you will get your 2 plus 2, which is nothing but your 4. Okay, now let's find the p of 2 value. So coming to the p of 2 value is given by 2 plus 2 into t square. That means it will become your 2 square minus 2 cube. So now here it will become 2 plus 2 plus 2 square will give you 4 and 4 into 2 will give you 8 minus 2 cube value is 8. Okay, so plus 8 and minus 8 will get cancelled. So now 2 plus 2 will give you 4. Okay, so if you observe here, we are having the p of 0 value we got as the 2 and p of 1 value we got as the 4 and p of 2 value also we got as the 4. So similarly find for the third one, where third one is given as p of x is equals to x cube. Okay, so for this we need to find the p of 0. So p of 0 will be given by 0 cube and p of 1 will be given by 1 cube and p of 2. So which is nothing but your 2 cube. So 0 cube will be 0 and 1 cube will be 1 and 2 cube will be 8. Okay, so once again you are having the homework question, that is nothing but your fourth question. Okay, so just answer that question and keep your answer in the comment section. Okay, so I gave you the 2 questions, so I am expecting the response from you and we will check it. Moving to the next is nothing but 0 of a polynomial. So I am saying that p of x, if I am considering as my x plus 1, okay, I need to take a value of x such that my p of x value will be equals to 0. Okay, so that means if you consider here, what is the value of x I have to take in order to get my p of x equals to 0? So can I take my minus 1? So minus 1 plus 1 will get cancelled and I will get my value as the 0. That means here my p of x, that means what is the x value I got? Minus 1. So p of minus 1 will give you 0. So as I am getting my polynomial value as the 0 by keeping the x value, whatever the value you are taking for the x, that becomes the 0 of your polynomial. Okay, so coming to the 0 of your polynomial is nothing but you can consider any of the value a, and if you place that value in your polynomial, you will get the value of your polynomial as the 0. Okay, now moving to the next important points for the polynomial, 0 of your polynomial is you can have any of your numbers. That means you can have your rational numbers or any of the real numbers can be your 0 of the polynomial. Okay, and depending upon the degree of your polynomial, we can say that how many zeros we are having for the polynomial. Okay, other pronunciation we can give for the 0 of your polynomial is nothing but solution of your polynomial. So if I am getting my polynomial value as 0 is nothing but whatever the value of x you are taking, that becomes the solution of the polynomial. Okay, so now for a linear polynomial, if you take the degree is 1, so that means the number of zeros will be also 1. Okay, and coming to the quadratic, so coming to the quadratic polynomial, the degree is 2. So how many zeros it is having? It is having the number of zeros as 2. And similarly for your cubic also. Coming to the cubic polynomial, the degree is 3 and the number of zeros of the polynomial will be 3. Okay, so moving to the next, for a non-constant, that means for a non-zero constant, you are having your 0. That means if I am considering any of my constant, like just consider 3. So for these 3 I am not having any variable x and I am not having the power of a variable which is nothing but 0. So if you are having a constant means that to a non-zero constant means then the number of zeros for that constant will be also 0. Okay, now let's solve a question on the 0 of a polynomial. So moving to the question, verify whether the given x values will be the zeros of your polynomial or not. So now if you observe here, they gave the polynomial here and they are giving the x value. So after placing the x value in the polynomial, if you got the value of your polynomial as 0, then x value will become the 0 of the polynomial. Okay. So let's solve it, and the first one, and you will understand. So coming to the given polynomial is p of x equals to 3x plus 1. Okay. And they gave the x value as minus 1 by 3. So now how can we find, how can we verify whether x equals to minus 1 by 3 is the 0 of your polynomial or not? Means, first of all, place the given x value in your polynomial. So now simplify it. So you will get 3 into minus 1 by 3 plus 1. So now denominator and numerator 3 will get cancelled, and here you will get minus 1 plus 1, which is nothing but your 0. So here after placing the x value as minus 1 by 3, I got the polynomial value as 0. So now these x value, which is nothing but minus 1 by 3, will become the 0 of the given polynomial. Okay. So now let's solve for the second question also. So moving to the second one, they gave that p of x equals to 5x minus pi, where x value is given by 4 by 5. Okay. So now if you look at here, 5 into x plus I am taking my 4 by 5, so which is nothing but 4 by 5 minus pi. So now 5 will get cancelled and you will get your 4 minus pi value. If you need in the decimal form, means you can take it as the 3.14. If you subtract it, then you will get your 4 minus 3 will give you. So decimal subtraction, you know, 4.00 minus 3.14. So now 0 taking borrow will become 10, and here also it will become 10. So you need to represent your 4 in the decimal point if you are subtracting the 3.14 means, because here it is in the decimal form, so you have to take the 4 in the decimal form also. So I am not having the decimal point, so my 4 can be written as 4.00 minus 3.14. 0 taking borrow, it will become 10, so 10 minus 4 will give you 6, and 10 once again giving borrow, so it will become 9. So now 9 minus 1 will become 8, and 4 giving borrow 3, so it will become your 0.86. I am getting 0.86, which is not equal to the 0. Okay. If my x value will become the 0 of your polynomial, means my value of your polynomial should be equals to 0. But coming to here, I am not getting the polynomial value as the 0. So that's the reason x is not a, that means x equals to 4 by 5 is not a 0 of the polynomial. Clear? So let's solve for the next one. So coming to the third question, they gave as p of x is given by x plus 1 into x minus 2. So now let's take that third one. So p of x is given by x plus 1 into x minus 2. Okay. And where x values are given as minus 1 and 2. So that means you have to check whether minus 1 is the 0 of the polynomial or not, and you have to check same for the 2 also. So now coming to here, p of minus 1 will become minus 1 plus 1 into minus 1 minus 2. So minus 1 plus 1 will get cancelled and you will get these values as the 0. So 0 into anything will give you the 0. Okay. Now let's check for the 2. So that becomes your p of 2, which is nothing but your 2 plus 1 into 2 minus 2. Now plus 2 and minus 2 will get cancelled, and here you will get your value as 0. Now 0 into anything will give you 0. If you observe here, after taking our x values as both minus 1 and 2, we are getting the polynomial values as the 0 and 0. That means x equals to minus 1 and plus 2 are the zeros of the given polynomial. Okay. So now let's take your next question as your homework question. Okay. Yes. Moving to the next. So we have seen what is the 0 of your polynomial. That means how can we define a 0 of your polynomial, and how can we check whether the given values are the 0 of your polynomial or not. Now moving to the next, we will discuss what are the methods to find the zeros of your polynomial, like your linear polynomial and quadratic polynomial. Okay. So coming to the linear polynomial, if you observe here, linear polynomial mostly we will use the basic form as ax plus b. Okay. Now this will be equals to our p of x. Okay. In order to find the 0 of your polynomial, we are going to equate the given polynomial to 0. So I am equating my ax plus b to the 0. Okay. Now plus b crossing equals to, using the transposition, we will get ax equals to minus b. And a is in multiplication this side. So crossing equals to, it will become your division. So it will become minus b by a. Okay. So if you take your x value as minus b by a, and if you place it in your polynomial p of x, then you will get your polynomial value as 0. So simply you can remember for your linear polynomial that if you are having in the form of a linear polynomial, minus b by a is the value that becomes the 0 of the linear polynomial. So now let's solve it. So the given p of x equals to 4x plus 2. Okay. So now equate the 4x plus 2 to the 0. So now we can take the 2 common from both the terms. So taking 2 common, you will get 2x plus 1, which is equals to 0. Now plus 1 crossing equals to, it will become minus 1. So here we got 2x equals to minus 1. And x equals to, 2 is in multiplication, crossing equals to, it will become minus 1 by 2. Okay. So that means if you take your x value as the minus 1 by 2, and if you place it in the polynomial, you will get your polynomial value as the 0. Clear? Now let's solve the another one. So coming to the another question, find the 0 of the polynomial p of x is equals to 5x plus 10. Another important thing, when you are having a question with you, just first of all identify whether it was a linear polynomial or the quadratic polynomial. Okay. If you use the same method for the quadratic polynomial, you won't get the zeros. So clearly you have to use this method for the linear polynomials. For that, first of all, make sure that the given question is in the form of a linear polynomial. So first of all, consider what is the polynomial they give. So it is of p of x equals to 5x plus 10. Now equate this 5x plus 10 to the 0. So on equating it to the 0, so you will get your 5x equals to minus 10. Okay. So now x will become, 5 will cancel 10 for 2 times. So it will be of minus 2. Okay. Now I told you that x value you can take it is your minus b by a. Okay. So let's see how can we apply this formula, that is nothing but your x equals to minus b by a. So another important thing is, whenever you are using the formulas, you have to mention the formulas what you are using in your subjective exam. If it was an objective exam, you can go for the option and you can use whatever the shortcuts you are having. But if you are having your subjective exam, like if you got the same question for the 2 marks, either you have to represent, that means either you have to represent there what is the formula you are using. So in the same way, if you want to simplify it, just simplify it by your own. Okay. So now consider the given polynomial in the standard form of a linear polynomial. So standard form of a linear polynomial is nothing but, so coming to the standard form, which is in the form of ax plus b. Okay. So now what is the given polynomial, that is the 5x plus 10. So compare it with ax plus b. So our b value will become 10 and a value will become 5. Okay. Now we can find it within the one step, that is nothing but our x equals to minus b by a, because we are having b value and a value. So now it will become minus 10 by 5. Okay. Now 5 will cancel 10 for 2 times. So if you observe here, on simplification and using the formula also, you are getting both the values same. Okay. So now let's see what is the method to solve a quadratic polynomial. So we know that the name itself will say that the quadratic polynomial is having the highest power, that is nothing but the degree as 2. So coming to the general form of the quadratic polynomial is in the form of ax square plus bx plus c. That means whatever the polynomial they give in the question, we are going to bring that question into the general form for our convenience. Okay. So how we are going to find the zeros for the quadratic polynomial means, we are having the different methods. First one is the factorization that we already learned in our previous grades, that is nothing but your grade 8 and 9. Okay. And coming to the another one is your quadratic formula. So let's see one by one. So coming to the first one is nothing but your factorization. So first of all, we are going to take the polynomial p of x equals to 2x square minus 8x plus 6. Okay. So now in the factorization, if I am considering it with my standard form, it is having ax square plus bx plus c. Okay. So here it is my plus b. So now my b value will become minus 8. So coming to the factorization, we know that 6 is going to be multiplied with 2. That means constant is going to be multiplied with the coefficient of x square. So which is nothing but your 12. Okay. So we have to consider the factor pairs of 12 such that the addition of the factor pairs or the subtraction of the factor pairs will give you the coefficient of the x. Okay. So let's just simplify what are the factor pairs you are having. So 12 comma 1 is the factor pair, and next one is your 4 comma 3, and next one is your 6 comma 2. Okay. If I am using my 12 comma 1, if I am doing addition or subtraction, 12 comma 1 is not useful. And similarly for 4 comma 3 also. 4 plus 3 will give you 7 and 4 minus 3 will give you 1. But here you need the minus 8. That's the reason 4 comma 3 is also not useful. Moving to the next, 6 comma 2. So if I am doing addition, 6 plus 2 will become 8. But here if you observe here means I am having my minus 8. So how can I get a minus 8 from the 6 comma 2 means minus 6 minus 2 value is nothing but your minus 8. Right? And if you consider here minus into minus will become plus. And 6 into 2 will give you 12. Okay. So that's the reason factor pair we are going to consider it as your minus 6 and minus 2. So here it will become 2x square. Now in factorization we mostly use the splitting the middle term. That means what is the middle term here? Minus 8x. So that we are going to split it and write it in the form of, that means the sum of two terms, which is nothing but minus 6x minus 2x plus 6. So moving further, from the first two terms you can take your 2x common, and from there you will get x minus 3, and from the next two terms also I am taking my minus 2 common. Okay. So here I left with x, and from the plus 1 minus came out. So we are having another minus here, and 2 3s are. So it will be x minus 3. Okay. Now students are having a doubt that this is the another term and this is the another term. No. Here we are having the 3 terms, and on simplification we brought the 3 terms to the 2 terms. So this is our first term and this is our second term. So from these 2 terms we can take out our x minus 3 common. So here it will become x minus 3. So from the first term if I am taking x minus 3 common, I am having still here 2x. And from the second term if I am taking x minus 3 common, I am having 2x minus 2. So now x minus 3 will give you the 1 0 and 2x minus 2 will give you the another 0. So how can we find those zeros means, if I am taking my x minus 3 equals to 0, I will get my x value as 3. Okay. That means one of the 0 of your quadratic polynomial will become 3. And moving to the next factor, if you consider means that becomes 2x minus 2 equals to 0. So taking 2 common you will get x minus 1 equals to 0 and x equals to 1. So therefore we got the two zeros of a quadratic polynomial as 1 comma 3. Okay. Let's solve the next one. So coming to the next one, we are going to use the quadratic formula in order to find the zeros of a quadratic polynomial. That is nothing but it is given by minus b plus or minus root of b square minus 4ac by 2a. So if you are like facing any issue with remembering, that means you can remember it as minus b plus or minus root of d, okay, by 2a. Clear? So now these d is nothing but, so here we are going to take x equals to. So these d is nothing but we are going to consider it as the discriminant. So coming to the discriminant is given by b square minus 4ac. Okay. So depending on the discriminant, we can say that what type of the solutions we are having for the quadratic polynomial. So if I am having my discriminant value equals to 0. So if I am having my discriminant value equals to 0, I will get my two zeros of a polynomial which are the real roots and equal roots. Okay. So if you are having discriminant is equal to 0, then the roots are real and equal. So now if you are having your discriminant value is greater than 0, so how can we say that the roots are real or not means you are having the discriminant is greater than 0 and equal to 0. In those two conditions only your roots will be real roots. And if you are having your discriminant less than 0, then the roots will be the complex roots. Okay. So if you are having your discriminant value equals to 0, the roots are the real roots and those roots are equal. That means you will get only 1 0. So now, and moving to the next is nothing but the relation between the coefficients of your polynomial and the zeros. So if you take your sum of zeros, so quadratic polynomial means you are having the two zeros, consider those two as the alpha and beta. If you take the sum of two zeros, then it will be given by minus b by a. Minus b is nothing but coefficient of the x by coefficient of the x square. Coming to the next is nothing but your product of roots. That means if you take alpha into beta, it is given by c by a. That means the constant term by coefficient of x square. So now let's solve the next problem. So moving to the next one. A rectangular pool with a length of 3 meters and width of 4 meters is surrounded by deck of the uniform width. Okay. So first of all, just make it a part, and there you are having your rectangular pool, okay, which is having the 3 meters length and 4 meters width. Now this pool is just surrounded by the deck which is having a width of uniform. So I don't know what is the uniform width. So I am going to consider that uniform width as x. So we are having all four sides as x. Okay. So now the total area of the pool and deck together is the 172 square meters. Now find the width of the deck. So if you observe here means completely this side, that means the length of the rectangular pool is the 3 meters. How can we get the complete figure length means, if you observe here we are adding x meters here and here it is also x. So complete length will become your 3 plus x. That is nothing but your 3 plus x, which is nothing but 3 plus 2x. In the same way, if you look at here, the width is the 4 meters and with these 4 meters you are adding the x and x. So now the complete width will become 4 plus 2x. Okay. So now for the complete figure, I got the length as the 3 plus 2x and width as the 4 plus 2x. Now apply the formula for the area of the rectangle. So area of the complete figure. So area of the complete figure is given by length into breadth, which is nothing but your 3 plus 2x into 4 plus 2x. Okay. Now here we are going to do the product of the binomials. That is nothing but use the distributive law. So now 3 is going to be multiplied with 4, so which is nothing but 12, plus 3 is going to be multiplied with 2, 3 2s are 6, so it will become 6x plus 4 2s are 8x plus 2 2s are 4 and x into x will become x square. Okay. So now it is further simplified as 12 plus 6x plus 8x will give you 14x. So 14x plus 4x square. So now they gave that this total area together is equals to the 172 square meters. So equate that to the 172. Now if you observe here, we can take the 2 common from our both LHS and RHS. Taking 2 common, 172 divided by 2 will give you, so 2 8s are 16 and here it is 1 left and it will become 12. So it is of 86. Okay. So now here it will become 86, which is equals to 2 will cancel 12 for 6 times. So 6 plus, and 2 will cancel 14 for 7 times. So it will become 7x plus 2x square. Okay. Now just bring your constant term to your RHS, or you can shift it and rearrange it like 2x square plus 7x plus 6 minus 86 equals to 0. Okay. So now if you look at here, we are having 2x square plus 7x minus 80 equals to 0. So on solving the area of the given figure, we got an expression, or we got an equation in the quadratic equation. That is nothing but your 2x square plus 7x minus 80 equals to 0. Now coming to this, how can we know that whether to use the factorization method or the quadratic formula is, if you are having the factors, that means if you are having the constant and the coefficient of x square, which will be easy to find the factors, you can go for the factorization method. Okay. And if you find that we are having a constant which will give you the complex roots, means you can go for the quadratic formula. That means finding the square is different, that means finding the factors for the constant is different, means you can go for the quadratic formula. And if you want to save your time, and then also you can go for the quadratic formula. Okay. But while doing the quadratic formula, first of all make the discriminant. So you have to find the discriminant value, which is nothing but your b square minus 4ac. Now compare the equation that you got in the form of ax square plus bx plus c equals to 0. From there you will get your A value as 2 and B value as 7 and C value as minus 80. Now our discriminant value will become B square minus 4AC, that means 7 square minus 4 into 2 into minus 80. Okay. If you observe here, minus into minus will become plus and 4 2s are 8. 8 into 80 will give you 640. Okay. So now it will become 7 square is the 49 plus 640, which is nothing but your 689. Okay. You got your discriminant value which is equals to 689. That means it is greater than 0. Okay. So from there you can say that we will get the real roots but not equal roots. So how can we find those real roots? Means use your formula minus b plus or minus root of discriminant by 2e. Okay. So use the formula and tell us what are the zeros, that means what are the values of the x you are getting, which is nothing but what is the width of the deck that you are getting. Okay. So now let's solve next another case based study question. So when it comes to the case based study questions, students will think that these are very long questions. But no. Okay. The questions are very easy if you read the information given. So coming to here, they gave that we are having a parabiotic shape of the cables along the suspension bridge help to carry the forces on the bridge to the top of the tower. Okay. And coming to here, that force is represented by an equation where P of x is ax square plus bx plus c. If you observe here, our three of the terms which are nothing but a, b, c, those are not equals to the 0. So now if you compare the given equation, if you observe here, we are having the power as the 2. This is the ax square plus bx plus c. So if you observe here, we are having the degree as the 2. That means it becomes the quadratic expression or the equation. So now let's see what are the questions we have to answer. Now then answer the following. Name of the polynomial on the basis of degree. So what is the degree of the polynomial we are having? So the given polynomial is represented as P of x equals to ax square plus bx plus c. So now if you observe here, we are having the degree of your polynomial as the 2. That means the name will become your quadratic polynomial. Okay. And moving to the next, name the polynomial depending upon the number of terms. Terms means how many terms you are having? 1, 2 and 3. In a polynomial, if you are having the 3 terms, means we are going to consider it as the trinomial. Okay. So now moving to the next, if the cable of suspension bridge is represented by P of x equals to x square plus x minus 6. If we are having a polynomial P of x which is in the form of x square plus x minus 6. Okay. Now find the zeros of the polynomial. So you can use your factorization method, because minus 6 you are having the factors as 3 and 2, because 3 2s are 6. You need the minus 6. So if I am taking my minus 3, means it will be giving you minus 1 on addition. That's the reason we are going to take 3 comma minus 2, because 3 into minus 2 will give you minus 6, whereas 3 minus 2 will give you plus 1, which is nothing but the coefficient of x. So now split the middle term as x square plus 3x minus 2x minus 6. So now from the first 2 terms you can take your x common. So there you will get x plus 3, and from the next 2 terms you can take minus 2 common and you will get x plus 3. So here it will become x plus 3 into x minus 2. Okay. Now what are the zeros of that polynomial will become? So zeros will become your minus 3 and plus 2. Okay. Now let's answer the next question. If the cable of the suspension bridge is represented by x square plus kx plus 3 and one of the zeros is the, so one of the zeros of the polynomial is 3, find the value of k. So here they are giving one of the 0 as the 3 and you have to find the value of k. So that means you have to take your value P of 3 equals to 0. So that becomes your x square, which is nothing but your 3 square plus k into 3 plus 3 equals to 0. 3 square will give you 9. 9 plus 3k plus 3 equals to 0. So now 9 plus 3 will give you 12. So here it will become 3k plus 12 equals to 0. And here it will become 3k equals to minus 12 Now 3 will cancel, minus 12 for 4 times. So finally you will get your k value equals to minus 4. Okay. So when you are thinking about the case based study means you mostly think that those questions are very tough and very difficult. It won't happen. Okay. First of all, read what is the given question. Of course, the question may be in the 4 lines, but we have to give it a try and we have to read it, right? So after reading, if you look at here, we are having mostly the simple questions in our case based study. And how can you get your 2 marks easily? By knowing the number of terms and by knowing the degree of your polynomial. Okay. So now moving to the next, if you want to know further more about our offline and online courses, you can scan this QR and you can go to the nearby offline centers. Okay. So that's all for today's class, and thank you for attending the session, and we will meet in our next session. Bye, take care.